3 fatal engineering failures just killed Elon Musk's Mars dream and could kill astronauts next. Ship 36 exploded instantly during fuel loading. Ship 35 flooded with deadly methane at 59 kilometers altitude. The fuel tube, bigger than Falcon 9, shattered under mystery forces. Here's the terrifying truth. SpaceX knew these flaws were lethal, but launched anyway. What secret discovery forced them to risk human lives? Let's dive right in. Here's what nobody tells you about SpaceX's success story. On May 27th, everything looked perfect. Too perfect. The first reused Super Heavy booster fired all 33 Raptor engines flawlessly, but SpaceX was secretly conducting an experiment that would destroy everything. They programmed the booster to dive back to Earth at a brutal 17-degree angle, steeper than any previous flight. Why? Because they needed data for Mars missions, where re-entry speeds are absolutely devastating. But here's the terrifying part. They knew this test would likely kill the booster. Picture this. Your car's fuel line is designed for normal driving, but you decide to test it during a Formula One crash. That's exactly what happened to Super Heavy's fuel transfer tube, a massive pipeline bigger than an entire Falcon 9 rocket. At 382 seconds into flight, the impossible happened. The aerodynamic forces crushed the transfer tube like a soda can. Methane and liquid oxygen mixed in a deadly cocktail, and the booster vanished in a fireball just 1 kilometer above the ocean. But here's the twist that changes everything. SpaceX engineers had run the calculations. They knew the tube would fail. They flew anyway because they discovered something that would haunt Mars colonization forever. The current design couldn't survive deep space re-entry. Every Mars mission would end in catastrophic failure. They had to break it to save the future. But at what cost? 3 minutes into what should have been routine, Ship 35's computers detected something that made blood run cold. Rising methane levels inside the nose cone. Not a leak, a time bomb. The fuel diffuser, a component meant to safely pressurize the methane tank, had catastrophically failed. Instead of directing gas into the tank, it was flooding the payload bay with explosive methane. Imagine a gas leak in your house, except this house is traveling at 17,000 miles per hour in the vacuum of space. Here's where it gets absolutely terrifying. The ship's systems kept working, masking the true danger. Pressure readings looked normal. The engines kept firing. Mission Control had no idea they were watching a flying bomb. But the methane had nowhere to go. For 2 critical minutes, it built up silently in the nose cone while the ship climbed towards space. Then the inevitable happened. Pressure skyrocketed while the main tank pressure collapsed. The ship tried to vent the gas, but it was too late. Liquid methane began flooding into the nose cone, freezing sensors and drowning controllers. Mission objectives failed one by one. Payload deployment impossible, in-space burn canceled, controlled re-entry abandoned. Ship 35 tumbled into the Indian Ocean like a methane-soaked death trap. But here's the chilling reality. If astronauts had been aboard, they would have been trapped in that frozen hell with no way out. What design flaw made this inevitable? SpaceX won't say, but the redesigned diffuser tells us everything. They know exactly what went wrong, and they're terrified it could happen again. June 18th, 2025. A routine test day at Starbase. Ship 36 sat peacefully on the test stand, ready for a simple 6-engine static fire. The same procedure SpaceX had done hundreds of times before. 18 seconds. That's all it took to go from cutting-edge spacecraft to twisted metal scattered across the Texas desert. The killer was hiding deep inside the payload bay, a composite overwrapped pressure vessel, or COPV. These engineering marvels store gases under crushing pressure using ultra-strong carbon fiber wrapped around thin metal liners. They're designed to be perfect. But perfection is an illusion. Here's the terrifying truth about COPVs. They undergo a brutal manufacturing process called autofritage, essentially torturing the vessel with extreme pressure to make it stronger. But this torture creates invisible microcracks that grow silently, like cancer in the metal. Current inspection methods can't detect these hidden flaws. They're time bombs with no visible countdown. When a COPV fails, it releases energy equivalent to a small explosion. The nitrogen gas erupts outward, causing structural failure, propellant mixing, and catastrophic ignition. But here's what keeps engineers awake at night. There are hundreds of these potential bombs on every Starship. Each one could trigger the same 18-second nightmare that destroyed Ship 36. SpaceX is now operating COPVs at reduced pressures and conducting additional inspections, but they're essentially playing Russian roulette with explosive chambers. How many more are ticking away, waiting to explode? Here's the question that haunts everyone. Why does SpaceX keep flying when they know death is possible? The answer lies in a calculation that most companies would never make. SpaceX isn't just building rockets. They're rewriting the laws of physics. Every component is being pushed beyond known limits because the alternative is never reaching Mars at all. Consider this brutal reality. NASA's Space Shuttle program took over a decade to develop and still killed 14 astronauts. SpaceX is attempting something infinitely more complex in half the time. The math is terrifying. Some failures are inevitable. But here's the twisted genius of SpaceX's approach. They're weaponizing failure. Each explosion teaches them something they couldn't learn any other way. The fuel tube failure led to stronger Block 3 designs. The methane leak drove a complete redesign of the pressurization system. Ship 36's explosion revolutionized COPV safety protocols. They're not just accepting failure, they're deliberately causing it under controlled conditions. It's development through destruction, and it's the only way to learn fast enough to beat China to the moon and reach Mars before it's too late. But there's a deeper truth hidden in these failures. They weren't accidents. They were birth pains of the most revolutionary rocket engine ever created. The Raptor engine represents something impossible, a full-flow staged combustion cycle engine that burns methane instead of kerosene or hydrogen. Think of it as the difference between a campfire and a controlled nuclear reaction. Most rocket engines waste fuel by dumping it overboard after running the pumps. Raptor burns every single drop twice, first in the pumps, then in the main chamber. It's like having a car engine that burns the exhaust fumes for extra power. But here's why these failures were inevitable. Raptor operates at pressures that melt the strongest metals known to humanity. The pre-burners reach 600 bar of pressure, enough to crush a submarine. Temperatures soar beyond the melting point of steel. SpaceX had to invent entirely new metals with exotic names like SX500 just to keep the engines from disintegrating. They use active cooling systems that pump cryogenic propellants through microscopic channels to prevent catastrophic melting. The fuel tube that failed? It had to withstand forces no component had ever faced. The diffuser that leaked? It operated in conditions that would destroy any conventional part. The COPV that exploded? It was storing gases at pressures that defy normal engineering. These weren't design flaws. They were the inevitable growing pains of technology that shouldn't exist. But here's where the story gets incredible. Each failure drove SpaceX to evolve Raptor from a complex nightmare into elegant perfection. Raptor 1 looked like what Elon Musk called a flying spaghetti monster. Cables and pipes everywhere. Heat shields and fire suppression systems protecting every vulnerable component. It worked, but barely. Raptor 2 cleaned up the design, removing unnecessary parts and integrating others. Thrust increased by 50 tons, while weight dropped by 400 kilograms. But it still looked like an engine designed by committee. Then came Raptor 3, and the world couldn't believe their eyes. It looked like SpaceX had stripped away the outer shell, leaving only a skeletal frame. But this wasn't incomplete. This was perfection. 560,000 pounds of thrust, 350 seconds of specific impulse, 170 pounds lighter than its predecessor. All achieved by following one brutal philosophy: the best part is no part. The best process is no process. SpaceX removed every component that could break, integrated everything that could be combined, and used 3D printing to create cooling channels that traditional manufacturing couldn't achieve. The result looks like alien technology because it essentially is. But strip away the engineering marvel, and you're left with a terrifying question. Can SpaceX make this monster safe enough for human flight? Each failure pushes back the timeline for NASA's Artemis program. Each explosion delays Mars colonization plans. Each catastrophic loss burns through millions of dollars in destroyed hardware. More importantly, each failure forces SpaceX to confront an uncomfortable truth. When astronauts finally board Starship, they'll be betting their lives that every possible failure mode has been identified and eliminated. The fuel tube that cracked under unknown forces, the diffuser that flooded the nose cone with explosive gas, the COPV that detonated without warning. How many more deadly surprises are hiding in the design? NASA's watching nervously. They've bet the entire lunar program on Starship's success. But these failures are raising uncomfortable questions. Can any rocket this complex ever be truly safe? Or is SpaceX pushing the boundaries of physics beyond what human engineering can control? Here's what SpaceX won't tell you. These 3 failures aren't the end. They're just the beginning. Block 3 Starship will be even more complex, with 42 Raptor engines generating 3 times the thrust of the Saturn V. More engines mean more potential failure points. Higher pressures mean more catastrophic consequences when something goes wrong. The diameter might increase from 9 meters to 12 meters, requiring completely new manufacturing processes, launch infrastructure, and safety protocols. Every change introduces new ways for things to go fatally wrong. But SpaceX has no choice. The window for Mars colonization is closing. Climate change, geopolitical tensions, and resource depletion mean humanity might only have one chance to become a multiplanetary species. Every month of delay gives China more time to reach the moon first. Every safety precaution reduces the chances of reaching Mars before it's too late. SpaceX is racing against time, physics, and human extinction. Something has to give. The question isn't whether more starships will fail. They absolutely will. The question is whether SpaceX can learn fast enough to save the astronauts who will eventually climb aboard these flying bombs. The next flight will tell us everything we need to know about the future of human spaceflight and whether Elon Musk's Mars dreams are worth the ultimate price. So there you have it. 3 fatal failures that revealed the brutal truth about humanity's most ambitious project. A fuel tube that couldn't handle Mars-level forces, a diffuser that turned spaceship into gas chamber, a pressure vessel that became an 18-second bomb. But here's what we learned. SpaceX isn't just building rockets. They're conducting the most dangerous experiment in human history. Every explosion, every failure, every catastrophic loss is teaching them how to cheat death at 17,000 miles per hour. The question isn't whether Starship will eventually work. It's whether we can afford the price of making it work. Because every month of delay brings us closer to a world where Mars becomes unreachable forever. Next week, we're diving deep into why China's lunar program might force SpaceX to take even deadlier risks. You won't believe what's really happening behind closed doors. But right now, I want to know what you think. Are these failures the growing pains of greatness, or signs that some dreams are too dangerous to chase? Drop your thoughts below. This conversation is just getting started. SpaceX engineers just went dead silent after seeing this footage from China's space station. NASA's top robotics expert whispered, "We can't build that." China deployed crawling robotic arms with 25-ton capacity and ion thrusters NASA has been trying to crack for decades. But the real shocker? There's one classified technology on board that's making U.S. space officials panic. What did China secretly install up there that has NASA scrambling? Let's dive right in. The footage was leaked 3 weeks ago. A shaky video from inside NASA's Johnson Space Center showing engineers watching live feeds from China's Tiangong station. You can hear the exact moment everything changed. Dead silence, then someone whispering, "How is this even possible?" What they saw defied everything they thought they knew about space technology. Here's what happened. NASA's top robotics engineer was reviewing routine footage when he spotted something that made him call an emergency meeting. China's robotic arms weren't just moving, they were crawling. Picture this, a 25-ton mechanical spider literally walking across the hull of a space station 400 kilometers above Earth. While NASA's arms are bolted to fixed positions, China's arms disconnect themselves and relocate to any point on the station. But here's where it gets insane. These arms can lift 25 tons each. That's like hoisting a fully loaded shipping container in zero gravity. NASA's best robotic system requires both arms working together to lift 58 tons. China's single arm does nearly half of that alone. The engineering behind this is theoretically impossible with current materials. The stress points should cause catastrophic failure. Yet there it was, working perfectly. NASA engineers have been trying to build crawling robotic systems for 15 years. Every attempt failed due to power requirements and structural limitations. China just solved it. How? That's what kept Pentagon officials awake for weeks. Remember those ion thrusters? This is where things get classified. Ion propulsion creates high-energy particle streams that can kill humans within minutes. NASA abandoned crude ion thruster integration after multiple safety failures in the 1990s. China mounted these thrusters directly on their crew module. Astronauts work just meters away from technology that should be lethal. Here's the problem. The physics don't add up. Ion thrusters require magnetic shielding so advanced that NASA's current technology can't produce it. The electromagnetic fields alone should interfere with every electronic system on the station. Intelligence sources suggest China developed a classified magnetic containment system. The exact technology remains unknown, but the implications are staggering. These thrusters allow Tiangong to maintain perfect orbital position while using 90% less fuel than chemical rockets. That's not just efficiency, that's next-generation warfare capability. But the real shock came when NASA realized what this technology actually meant. 2 years. China built their entire space station in 2 years using 12 launches. The International Space Station took 10 years and 30 missions. NASA engineers called it mathematically impossible until they saw the classified analysis. China didn't just build faster. They revolutionized space construction itself.